Hello friends, welcome to my channel PSU Aspirants. In this video, we will see thyristor commutation techniques classification and natural commutation from GATE and ESE exam questions point of view. So firstly, let's see what is commutation of a thyristor. So as we know, thyristor is a semi-controlled device in which the turn off is normally through supplying a gate current or gate pulse, but for turning off, we need some external circuitry because turn off should be in our hand. That's why the external circuitry used to turn off the thyristor is called as the thyristor commutation techniques or thyristor commutation circuitries. So let's see methods of turning off the thyristor. So the first method is by making the thyristor current less than the holding currents. As we know, the holding currents is generally in terms of milliamperes. So by making the thyristor current nearly equal to zero, current flowing through the thyristor nearly equal to zero, we can turn off the thyristor. Second thing is by applying a sudden large value of the reverse voltage across the thyristor. Hence, by applying VAK less than zero, suddenly brings back the thyristor to the reverse blocking mode. That's why second technique is by negative impulse supplying to the thyristor. Now let's see what are the classification of the commutation techniques. So basically classification is in two groups. First is the natural commutation and second is the forced commutation. In natural commutation, we don't need any external circuitries. The commutation occurs with the help of the line voltage or AC supply available only. It is also called as class F commutation. The uses are in rectifiers and AC to AC voltage controllers which have AC supply in its source. The second is the forced commutation. It is basically used where we have a DC supply at the input. For that, there are four types of method used: class A, class B, class C and class D commutation. Load commutation, current commutation, impulse commutation and the voltage commutation. Its uses are in DC to DC converters which were buck boost and inverters. Let's see the natural commutation technique, that is class F commutation. In this technique, the sinusoidal nature of the AC supply supports the thyristor commutation. Now it has natural zeros at 0, pi, 2 pi. That will be helpful in making the current zero through the thyristor. Remember, there were two techniques. First was current and second voltage. So here we will make current through the thyristor zero. So here is the circuit of half wave rectifier. This is sinusoidal supply, thyristor and output voltage across the resistive load. Whenever at angle alpha, gate pulse is given to the thyristor, it gets on. So the output voltage appears across the R load, that is the half wave waveform from alpha to pi only. Now the current through the resistive load is given by I naught equals to V naught by R, that is same waveform. That is, here I have written the I naught. From alpha to pi it is coming. Now see, when pi comes, at that time the current is naturally becomes zero without any circuitry use. So at this point thyristor will automatically get turned off because beyond that the supply voltage will be going negative. So as soon as the output voltage becomes negative, current starts becoming negative, but thyristor cannot conduct in reverse direction, so it ceases to conduct and we get only up to pi waveform and it stops at pi. The voltage across the thyristor we can see here, that is from 0 to alpha, it is in forward blocking mode. Here it is conducting in forward conduction mode, and when the voltage across the thyristor becomes negative due to the Vs waveform, it is in reverse blocking mode. the parameters important are the conduction time of the thyristor T conduction, that will be equals to, this is whole is pi minus this much alpha. So this one is pi minus alpha. Second is the off time, the time for which the thyristor remains off, that is total time of the cycle 2 pi minus of conduction time, that is pi minus alpha. That will come out to be pi plus alpha. So friends, if you enjoyed this video, please like the video and subscribe to my channel PSU Aspirants.